Hello viewers, and welcome once again. We are still under logic, Christ Almighty God's algebra. In our last tutorial, we treated law of commutativity, in conjunctive statement. Today we are going to treat law of commutativity in disjunctive statement. Let us start. Law of commutativity. P or Q is equal to Q or P. This statement is typical example of law of commutativity in disjunctive statement. If you observe the equation, you find out that P at the left-hand side of equation is the first disjunct, while Q is the second disjunct at the left-hand side of the equation. But at the right-hand side of the equation, Q becomes first disjunct, while P becomes second disjunct. That means there is an interchange between P and the Q. So, but it preserves equivalence. It is law. It preserves equivalence because whenever P or Q is true, also Q or P is also true. Whenever Q or P is false, also P or Q is false. Let's prove the statement. Proof. Suppose P or Q is equal to Q or P. This is our hypothesis, that we assume that P or Q is equal to P or Q. Since whenever P or Q is true, also Q or P is true. Vice versa, whenever Q or P is false, also P or Q is false. Since this is the case, we are going to transform this statement into biconditional statement. That is, if and only if P or Q, if and only if Q or P, since whenever the left disjunct is false, also the right disjunct must also be false. Whenever the right disjunct is true, also the left disjunct must also be true. If that is the case, it says that in the evaluation of the statement, we are going to obtain tautology. There's no possibility of getting falsity in this statement when we evaluate it. Always truth. We say that statement is tautology. Is tautology being justified by logical equivalence? Being justified by logical equivalence. Since whenever the left disjunct, whenever the left equivalent is true, also the right equivalent must also be truth. If that is the case, we say that if and only if P or Q implies Q or P. That means whenever this left equivalent is truth, also the right equivalent must also be truth. We then transform it to conditional statement and it still preserve tautology. Because whenever the antecedent is true, also the consequence must also be true. In the environment of this statement, there is no possibility of obtaining falsity, always truth. We say that it is tautology. Is tautology being justified by logical implication? Biological implication. Since the statement is tautology and it is truth, the statement is truth, there's no possibility of ascertaining falsity in statement. We then deduce that P or Q exists, and it's certain that P or Q exists, and also certain that Q or P exists. P or Q, that is the assistant, exists, and also Q or P, that is the consequent, also exists. So say if and only if P or Q is logical implication of Q or P. That means the antecedent is logical implication. That is certain that P or Q proves Q or P. That means it is certain that the antecedent proves the consequent. That's why we say that P or Q is logical implication of Q or P. If P or Q is logical implication of Q or P is true. Also, if and only if P or Q is equal to P or Q. That means the logical implication is equal to itself. That means whenever the P or Q is true, also P or Q is true. Whenever P or Q is false, also Q or P is also false and is logical equivalent. Is logical equivalent. They are equal. That means it is law being justified by identity. That is the sameness. So it is true that P or Q is equal to P or Q, justified by identity. We continue to that side. So if and only if P or Q is equal to P or Q or bracket not P and G, P. You see that not P and P has now been added to P or Q. That is have P or Q in bracket or bracket not P and the P. Is sent in as P or Q. Because not P and P is equal to contradiction, that is equal to F. In evaluation of not P and P, we always obtain falsity. There's no case of obtaining truth, always false. So being justified by law of complement. So and when contradiction is added is or with any statement, is said as that statement. So P or Q is equal to P or Q or bracket not P and Q. So it is ordained by law of identity, justified by law of identity. By law of identity, being justified by law of identity. So if and only if P or Q is equal to Q upon not P or bracket not P and the P. We have seen that this P or Q has now been transformed to not P implies Q. That means Q upon not P through first educators law. Through first educators law. By first educators law. By first educators law. It still maintain logical equivalence. Now we are going to distribute the implication you have now generated from the disjunctive statement. We are going to distribute it between not P and the P. So if and only if P or Q is equal to Q or bracket not P upon not P and P upon not P. We have now seen that this not P as that is among not P and the P, and is still among not P and the P, and the statement has now been extenuated. It has now been intensified because this is still law. Is still maintained, is still law because not P upon not P is ontology. Ontology and with any term is it as that term. That means this is Q or P upon not P, and P upon not P is P. So it's still equivalent. It's still logical equivalent to Q or P or Q. So being justified by distribution of implication. We are going to transform these conjunction statements here to disjunctive statements because this implication which we use to distribute between not P and P is being generated from disjunctive statement. So when you want to reverse it, it's going to also be in disjunctive statement. means. That means if and only if P or Q is equal to Q or bracket, not P or P and bracket, P or P, P or P. So these have been transformed to this statements, these conditional statements that have transformed to conditional statements. That means not P or P, a breakdown and corrective, and P or P. P, not P or P, a breakdown and corrective, bracket, P or P. That is its logical equivalent in disjunctive statement being justified by first eject law. First eject law. So if and only if P or Q is equal to, you see that this not P or P is equal to T. That means what is truth. The version of this not P or P is T. That means tautology. And when T is and with any term is same as that term. So we have Q or bracket T and bracket P or P being justified by law of complement, because this not P or P is equal to T by law of complement. By law of complement. We continue here. So if and only if P or Q is equal to, you see that when this topology and with any term as a term, that means we have Q or bracket P or P being justified by law of identity. By law of identity. Yes, by law of identity. That means when T is and with any term is set as that term, being justified by law of identity. So if and only if P or Q is equal to Q or P or P is equal to P by law of idempotent. Law of idempotent. Because by law of idempotent, P or P is equal to P. So we say is P being justified by law of idempotent. Law of idempotent. We have now proved P or Q is equal to Q or P. We then concludes, thus P or Q is equal to Q or P. Both We have never finished our proof since it is law. Since it is law, we're also going to prove the converse that also the other side is also equal to the other side. So, by the law of extensionality, we are going to establish that it is truth that P or Q is equal to Q or P. So, we are going to prove the converse. So, conversely, Q or P is equal to P or Q. So suppose Q or P is equal to P or Q. We assume that this is truth. That means Q or P is equal to P or Q is our hypothesis. Since we assume that P or Q is equal to P or Q, we are going to transform it to by conditional statement because whenever the left answer of the equation is truth, also the right answer of the equation is also truth. Whenever the right answer of the equation is false, also the left answer of the equation is also false. If that is the case, we are going to bring it to by conditional statement and say that it is tautology. If and only if Q or P, if and only if P or Q is tautology. We have now transformed this equation to biconditional statement. If this is true, also this biconditional statement is also true. Because whenever the left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is false, also the left equivalent is also false. If that is the case, we say that in the evaluation of this statement, in the evaluation of statement, we say that it is tautology. That means when the statement is being validated, there's no possibility of getting falsity, always truth. We say that it is tautology. Being justified by biological equivalent. Biological equivalent. So if and only if, since whenever the left equivalent is truth, also the right equivalent also must also be truth. We then transform it to conditional statement and it will still preserve tautology. So if and only if Q or P implies P or Q is tautology, because in the evaluation of this statement, when we relate this statement, there's no possibility of getting falsity, always truth. Because whenever the antecedent is false, is true, also the consequence must also be true. If that is the case, we say that the statement is tautology, being justified by logical implication. By logical implication. Being justified by logical implication. Since the statement is truth, there is no way we can obtain falsity in the evaluation of the statement. We then deduce that the antecedent is logical implication of the consequent P or Q. That means it is certain that the antecedent exists. It is certain that the antecedent exists. So we say that the antecedent is logical implication of the consequent. That is, if and only if Q or P is logical implication of P or Q. If this is truth, that Q or P is logical implication of P or Q, then also this is also true. So if and only if Q or P is equal to Q or P, being justified by identity. By identity. That means the logical implication of P or Q is equal to itself. That means Q or P is equal to Q or P. Because whenever Q or P is true, also Q or P is also true. Whenever Q or P is false, also Q or P is also false. Because they are the same names. That's why I say it's being justified by identity. If and only if Q or P is equal to Q or P or brackets not Q and Q. You see that not Q and Q is being added to Q or P and is still equivalent to Q or P, because not Q and Q is equal to contradiction, and it is equal to falsity. There's no way we can obtain falsity. There's no way we can obtain truth in this evaluation of not Q and Q. Always falsity. And when it is all with this term, it becomes the same thing as this term, that is Q or P. Because by law of implication, this not Q and Q is equal to F. And F or with Q or P is equal to Q or P, being justified by law of identity. So we say that if and only if, so being justified, this is being justified by law of identity. By law of identity. You know, by law of identity. We then continue to this side. You continue to this side. You say Q, if and only if Q or P is equal to, you have P or not Q or bracket not Q and Q. You have now transformed this disjunctive statement Q or P to conditional statement. That means it's equivalent, it's logical equivalent to conditional statement true by first educates law. So by first educates law is being transformed to conditional statement. That is by first educates law. That is to say that bracket bracket Q or P is equal to not Q implies P implies P. Say if and only if and only if you're going to distribute this not Q between not Q and the Q, it will have Q or P is equal to P or bracket not Q upon not Q and Q upon not Q is still equivalent to Q or P. It maintains logical equivalent to Q or P. Being justified by distribution of implication. Being justified by issue of implication because this not Q, that means the implication, is now being distributed between not Q and the Q. That's why I have not Q upon not Q, not Q upon not Q, and Q upon not Q. Now I'm going to transform these conditional statements that in this bracket, that's Q upon not Q and Q upon not Q. That means transform it to to disjunctive statement because this Q is being generated from disjunctive statement. That means this Q or P, which is disjunctive statement. So when you want to revise it, it's going to also be in form of disjunctive statement because the implication is being generated through disjunctive statement. That means if and only if Q or P is equal to P or bracket not Q or Q and bracket Q or Q. Being justified by first educates law. Being justified by first educates law. First, being justified by first educates law. That is to say that bracket, or let's leave it because there are two. That means this not Q or Q is logically equivalent to Q, not Q upon not Q. That means not Q implies not Q. That means true by first educates law. Presenting Q upon not Q. It is Q or Q. Since we have now transformed it to its logical equivalent in disjunctive statement, you can see that this not Q or Q is equivalent to T, is equal to tautology. That means by law of complement, it's equal to tautology. And tautology and this Q or Q is equal to Q or Q. So you say if and only if Q or P is equal to P or bracket T and bracket Q or Q or Q being justified by law of complement. Being justified by law of complement. By law of complement. If and only if Q or P is equal to P or bracket Q or Q. You will see that this T topology and bracket Q or Q is equal to Q or Q because whenever a topology is AND with n term is equal to that term by law of identity. By law of identity, so whenever topology is AND with n term is same as that term. That's why it is T and bracket Q or Q is equal to Q or Q. So being justified is still maintain logical equivalent. It still maintain logical equivalent. So being justified by law of identity. Law of identity. So if and only if Q or P is equal to P or Q, you see that this Q or Q is equal to Q. By law of idempotent, Q or Q is equal to Q. That's why I have P or Q. So being justified by law of idempotent. By law of idempotent. Law of idempotent. Then if and only if he said thus, since I now prove that Q or P is equal to P or Q. That means the converse of P or Q is equal to Q or P. The converse is Q or P equal to P or Q. We say thus. Q or P is equal to P or Q. So by the law of extensionality, we have now proved that P or Q is equal to Q or P. Since I now proved the converse, it is now agreed by the law of extensionality that P or Q is equal to Q or P and is law of commutativity. We then conclude, say, therefore, P or Q is equal to Q or P. That means is law of commutativity in disjunctive statement. We have now proved that P or Q is equal to P or Q. That is the law of commutativity in disjunctive statement. So at this junction, we will draw our curtain. Thank you, viewers.